In this video, we're going to talk about closures. Now, you've already seen closures before in JavaScript, I bet. In fact, we've seen a couple examples so far in this series, but I want to formally define them, talk about them, how we can use them, and how awesome they are, actually, because they are pretty much one of the most basic fundamental building blocks of the language. But see, we've kind of been building up to this video since the beginning of this section because closures have a lot to do with scope. In fact, they're all about scope. So let's go ahead and just define what a closure is. It's simply a function that refers to variables in its parent scopes. And that's it. But it's so powerful, so powerful. A lot of fun stuff you can do with them, but you really need to understand all the scoping issues and how to, well, formally define a closure for you not to run into the potential issues that people often run into. So I want to provide a really solid foundation of what exactly a closure is. We won't look at crazy complex examples in this video, but we'll look at simpler examples that will hopefully help solidify the concept for you. So let's go ahead and get started. I'm going to start off with just a little bit of just a silly example, just a little bit of syntax that I hope you guys are comfortable with by now, but I want to go ahead and we're on example 18, I think. Nope, 17. Derp. I can count good. Okay, so let's look at an example of how we can pass functions into each other. That's how we're going to start this video off. Just the basic concept of a function as a variable. So I'm going to do example 17, and it's going to take in a parameter called callback, and I'm going to invoke callback as if it's a function 3 times. Then what I'm going to do is I'm going to say... well, actually, let's invoke callback with a argument. So we'll do 1, 2, and 3, and then I'll invoke example 17, and I'll pass in a function that takes in an argument, and it'll simply console log out just arg, I guess, and we'll hit control it. So really simple stuff that's going on here. We have a function expression we're passing in as an argument, and then example 17 we are invoking it 3 times. Now, funny, this isn't, you wouldn't necessarily call this a closure because we're not capturing any variables in the parent scope here, but this part of this video isn't about specifically closures. It's being comfortable with the idea that functions can are first-class citizens. This is an example of what's called a higher order function, the example 17, because it accepts a function in as a parameter. And this is such a powerful concept, but such a difficult thing to sort of distill for people, the ability to write generic kind of functions that take in other functions that can change the behavior of them. And it's something that as a JavaScript developer, you're going to have to get very, very, very used to when writing your code. Let's do some more more functional stuff. This is kind of functional programming here. Functional programming is just it's a programming paradigm that emphasizes the practice of returning functions and accepting functions, specifically pure functions, which I'll define here in a moment. And it's a very powerful thing, and it's kind of what we're building up to when we talk about closure. So I just want to show a couple other examples of how we can use functions, how we can play with functions, manipulate functions, pass them around, all that fun stuff. So what I'm going to do here is let's do something really, really straightforward. Let's write a very common sort of higher order function that, in fact, is actually, we're going to write this function, but there's a built-in version of this function already, but we're going to write it out and just to try to get a good grasp of higher order functions. So let's go ahead and write a function filter array, and it's going to take in an array and a predicate. Now, predicate in English, it just means a condition. So the predicate parameter here is going to be a function that will return true or false if we want the resulting array to include an item. So this function is, all it's going to do is it's going to create a result array, then it's going to loop over the passed in array. So I smaller than array length, I++, and we'll do var item equals array at I. Then I'll say if not predicate item, continue, and then I'll say result push item, and then down here I'll say return result. So it's a very generic function that allows me to filter out items, or filter in items rather, in an array. Now, this is actually kind of interesting. I do want to point this out. This is a stylistic thing. You'll notice I say I'm calling the predicate function, which will return true or false if it wants this particular item to be included in the array. And you'll often see people write this a little differently. You'll often see people do if predicate item, then result push item. You'll commonly see it written like that. I generally don't write code like that. Instead, I do a sort of fail fast where I try to attempt to reduce the amount of indentation in the code. It makes it a lot easier to read, in my opinion. So we're saying if not predicate item, then continue the loop and don't do the thing down here. And then if the predicate returns true, then push it on the result. It's a stylistic thing. Reducing indentation, if you get used to this style of coding, can greatly increase the readability of your code. So how would we go about using this filter array function? Well, we need an array first. So I'm going to do var array equals 1, 2, 3, 4, 5, 6, 7. And then I'm going to say var result equals filter array, passing in array, then passing in a function that takes in an item, and will return item is smaller than 4. And then I'm going to console log out result. So what do you think the output of this is going to be? We have a basic filter function that is going to include items that are smaller than 4 in the result. So I'm going to hit Control S, and we see an array of 1, 2, and 3 because those are the only 3 items in the array that are less than 4. So if you haven't written code like this before, I actually highly encourage you to go out and type this out. Type this out. Get used to passing in functions to functions, because we've taken this code, this kind of code that you've probably written a million times before. You create an array, you loop through the array, you test it to see if it matches some criteria, and then you add it to the result array if it does, right? You've done that a lot, but we've taken the ridiculous amount of code you'd have to write to do that, and we've condensed it into simply 3 lines right here. In fact, the code would even get cleaner if we used ES 2015 arrow syntax, but we're not going to be using that syntax until the next section when we talk about this, the keyword this. So yeah, this is a higher order function. Let's talk a little bit, let's do something, another functionally thing that you'll see often, and that is returning a function. How often have you returned a function? It's actually a very powerful technique. And what I want to do is I want to write a function called lessThanFilter that takes in a parameter called lessThan. And lessThanFilter will return a function that takes an item, and we'll terminate that because that's a function expression, and it'll return item is smaller than less than. So what I can do with this, and I'll explain what's going on in a second here, but what I can do with this is I can say var less than 5 equals less than filter 5, and I can say console log less than 5, and let's pass in 3, then let's invoke less than 5, less than 5, not less than filter. I'm going to make sure, less than 5, and then let's do 10. So what do you think the output of this is going to be? We are invoking less than 5 twice and just outputting the result to the console. Let's hit Control S and we see true and false, which is the behavior we expected. So what's happening here? Well, we're kind of making a function factory. And this is something that you'll see all the time in JavaScript, where you write a function that returns another function. Super, super awesome, because this less than 5 variable now has a function in it. This function was created by invoking less than filter, and we can now invoke this variable as if it was a function. We've constructed a function. Think of it like a function factory or something. So, and this is, by the way, spoiler alert, this is a closure right here. We have a closure. We're creating a closure every time we invoke less than filter. We'll talk more about that later in this video. So how do we use this? What's the purpose of less than 5? Well, I can go ahead and I can say, let's do console log filter array, passing in our array, the array variable that we declared up here. And then I'm also going to pass in less than filter of 2. And hit Control S. And now the result that we get is a array with single element of 1, because the only thing in that array that was less than 2 was 1. So we see that by creating this little function factory thing, we're able to even shorten our code even more. And this sort of functional composition is very paramount to functional style programming that you'll see a lot of JavaScript uses. And it's very, very, very important to understand. This code might look a little terrifying, especially if you're relatively new to JavaScript. But what's important to do in that case, if it does look a little scary, is to write it yourself and really try to figure out what's going on here. But yeah, so this is a closure. This is a closure right here. We're returning a new function, and that function has a scope, but it also takes along with it the scope of the less than filter. So every time the less than filter, so let's break this down to 2 things. First of all, we have the lexical analysis of this function. And the lexical analysis determines which variables are bound to which scope. And we see that we're creating a new scope here by having this function, and it has one variable in it, less than. Then we're creating a function expression here, which creates another scope, and it has item in here. And item is bound to the parameter of the closure, and less than is bound to the parameter of the factory function or whatever. Now what's interesting though, and we'll see another example of this in a moment, what's interesting though is every time we invoke lessThanFilter, we get a new instantiation, a new copy, not really a copy, but a new instance would be a better, more accurate term, a new instance of the lessThanFilter scope, right? So it does have a lexical scope, which is why this less than is bound to that less than. That's the lexical scope there. But when we call it, we get a new instance of this closure that uses a different instance of the scope. Insofar as the fact that we wrote lessThanFilter of 5 and then lessThanFilter of 2, we get 2 instances of this closure. And each instance of the closure carries around with it a copy of the scope of lessThanFilter with whatever is passed in. Now, if that doesn't really make sense, I have another example for you guys. But again, a very, very sort of interesting, sort of generic sort of programming paradigm I'm showing you guys. And I find it really cool, by the way. But stuff and things. Returning functions is not scary. It's not as scary as I know when I started writing JavaScript and I started looking at other people's code and was really confused about the whole like returning functions, like functions that return function, blah blah blah, can get very confusing, but it doesn't have to be. It's something that it does just take time to get used to. But let's go ahead and do another example here. So I'm going to copy this and then I'll comment out our filter array example. So let's go ahead and do example 19, and let's do something fun. With this example, what I want to emphasize is the difference between the lexical scope and the scope at runtime. And the fact that every time we call a function create a new closure, we're actually going to get a new instance, a new block of memory that doesn't affect any previously created blocks of memory. So let's go ahead and write a function validate password. And what this is going to do is we're going to create a local variable called count, and we're creating this variable within the scope of validate password. So this variable is bound to that function, right? And then we're going to return a function that takes in a variable, a parameter called attempt. And I'm going to say console log validator of password called. And for this, I'm actually, before that, I'm going to do called count plus plus to increment called count. And then called, and then I'll do called count. And this line is getting really long, so maybe I'll break it out like that for you guys. And then I'll do, whoops, I'm missing a plus. Thank you, Visual Studio Code. And then times. Maybe I can get that all. I can kind of get that all. Maybe I'll just expand this. Okay, and then I'll say return attempt equals password. So a couple interesting things to notice here about this. There's a lot going on that that I want people to really pay attention to. And the first thing is obviously we're creating this function that takes in that has this function. The scope has 2 variables in it. It has password as the parameter and called count, which is just a local variable to this function. But then we're returning a function expression, and this is a closure. How do we know it's a closure? Well, we're referencing, as you can see, variables outside of its scope that are attached to its parent scope, right? So we're manipulating right here. We're not only manipulating, but also reading a variable declared in the past scope or the previous scope. And we're also returning attempt equals password. So the idea, well, we can do a strict equality there, I guess. What's going on here is we're now comparing the attempt passed into the function return, passed into the closure, with what was created with that factory function, or whatever you want to call it. So I'm going to do var validate. Let's do validate A equals validate password A. We'll do validate B equals validate password B. So we have these 2 functions, validate A and validate B. And these are global. These are going to be global. So I'm going to invoke them from the console, I think. I'm going to do validate A invalid. And you'll notice it says validator of password A called 1 times. Now, if I do it again, invalid, validator password A called 2 times. So I'm invoking this function right here that was created by calling this function, which returned a function. Super fun function stuff. And you see it's returning false. If I did validate a password A, it'll say validator of password A called 3 times, true. Now, what do you think the output will be if I do validate B password B? So now I'm invoking validate B. What do you think the output is? You'll notice that every time I invoke this closure, I'm getting a 1 times, 2 times, 3 times, right? So what do you think the output will be? Well, if we do it, validator password B called once. And it returned true because I passed in the right password. So we called it once, which is interesting. Remember, if I do validate A, now we're at 4 times. But if I do validate B, now we're only at 2 times. So we see here that by creating this function expression, by this function expression having been evaluated by the JavaScript runtime, what we're getting is we're getting a new instance of both its scope as well as its parent scope. So the called count, we have 2 instances of the called count variable right now. One is stuck in this closure, and the other one is stuck in that closure. So it's often confusing for people, I think, and it was when I was learning JavaScript and getting used to this this sort of programming paradigm. It's interesting to think of your variables in 2 sort of contexts. You have your static scope, which is determined by the lexer, and then you have your instances of your scope, which are created every time you evaluate code that results in a new closure being instantiated. And we can actually see that sort of visually. I don't know how this is going to look, but I'll try it anyway. If I go into my source tab and open up my JS file, we can kind of see this visually by putting it in the debugger. I can go ahead and put a breakpoint right here on validate password. And notice I'm not putting a breakpoint on validate password. I'm putting a breakpoint on the closure that validate password returns. And I can come over here and I can do validate a password A. And now we're paused, right? So execution is paused. We have a breakpoint here. You can see that we're paused in debugger. But over here, we can actually go ahead and we can look at a couple interesting things. First of all, we have the call stack, which is interesting. The call stack is who invoked this function, and the function that invoked this function is this VM3 blah 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 blah. And that's an internal wrapper in Chrome for the console down here. But we also have the scope, and check this out. We have local, closure, global. It's actually a stack. Our local scope contains our attempt, which is our parameter, and our this. Well, again, we're talking about this in the next section. Then we have the closure, which is validate password. And notice how it has a called count of 4 and a password A. But if I resume it and then invoke, instead of validate A, if I invoke validate B, notice how we have the same structure, right? Same structure. We still have our local scope, our closure, and our global scope, but this is a different closure, because we see that called count is 2 and our password is password 2. So the called count again is right here, and you see its value is 2 and password is password B. So we see that by returning this function, we're inside of a function. Every time we call this function, a new sort of place in memory is created for us. And that place in memory will stick around. This closure right here, these variables that are closed over, will stick around in memory as long as a reference to validate A or validate B exist. That's actually a common source of memory leaks in JavaScript, where you have a closure that has access to all of its parent scope's variables. And because it has access to them, it keeps them around in memory, but then you forget to set validate A to null, for example, or undefined when you're done using it. And then that closure is still sticking around in memory because it can't be released by the garbage collector. So I have a couple more, not quite done with closures yet. So I think we'll do part 2 of closures here in the next video. And hopefully with a couple more examples, things will start to make sense. So we'll see you guys then.